When discussing weather forecasts, a term that often comes up is the jet stream. It's often used to describe why a specific weather pattern will exist, but commentary is usually limited to it'll be going this way, so this will happen. But what exactly is the jet stream, and what makes it so influential in shaping the weather? Now, before we get into all of that, I'd appreciate you to like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Alright, so what is the jet stream exactly? Well, to put it simply, it's a narrow and extremely fast-moving river of air that circles the globe at altitudes similar to the cruising altitude of planes, a detail which will be important later. There are four major jet streams that circle the planet, those being the polar and subtropical jet streams, with one of each for both hemispheres. As you probably guessed, the polar jet stream resides in the mid to upper latitudes of the planet, while the subtropical jet stream is, well, in the subtropics. The reason the jet streams even exist is largely due to how wind exists in the first place, but amplified to the extreme. You see, wind is caused by differences in pressure in different air masses. When you have a high pressure region adjacent to a low pressure region, air will want to move towards the low pressure, creating wind. The bigger the difference in pressure, the more wind there will be. Normally, air will try to flow until the pressures are equal, at which point the wind stops blowing. However, at the latitudes where high-pressure subtropical air masses meet the lower pressure regions closer to the poles, the Coriolis effect deflects the moving air along the boundary between the two regions, creating a fast-moving wall of air between them, the jet stream. As such, the jet stream can more or less be thought of as a boundary between the polar atmosphere and the equatorial atmosphere. But this boundary is not by any means a straight line. The strength of the air masses pushing on it will vary considerably, as well as the speed of the jet stream itself, so this can cause it to buckle dramatically over just a couple thousand miles. This gives you heat domes and polar vortexes. These are caused by particularly powerful air masses building up and pushing much further north or south than they usually do. But beyond that, smaller changes in the jet stream will have an influence on the weather, with a ridge or northward curve often indicating warm and calm weather beneath it, and a trough or southward dip usually containing cooler and stormier weather. But does the jet stream have any use beyond driving the weather? As it turns out, it does. Remember when I said that the jet stream tended to flow at the cruising altitude of a plane? Well, this fact actually has tremendous implications in routing airplanes, especially when it comes to longer haul flights. The typical cruising altitude speed of a plane is about 570 miles per hour or 920 kilometers per hour. However, the jet stream flows eastward at about 100 miles per hour or 160 kilometers per hour on average, and in rare cases, it can be even greater than that. Over transatlantic and transpacific distances, where flights take thousands of miles in 10 to 12 hours or more, that extra speed adds up significantly. As a result, airplanes will often take a somewhat longer route to get to their destination if it means flying with the jet stream, as the longer distance is canceled out by the significantly faster speed the plane reaches and then some, saving both time and fuel. In rare cases, the jet stream can accelerate planes to above the speed of sound, though no sonic boom is produced since the plane is still moving at subsonic speeds relative to the air around it. All told, flying with the jet stream can save upwards of an hour on some oceanic flights, a huge deal given how long these flights are. However, since the jet stream only flows eastbound, westbound flights just take as direct a line to their destination as possible, which tends to make these flights quite a bit longer. So now that we know what the jet stream is and why it's important, how has it been affected by human-caused climate change? Well, remember that the jet stream exists thanks in large part due to the contrast between the warmer air masses nearer to the equator and the colder air masses close to the poles. The thing is, though just about everywhere on Earth is warming up, different parts of Earth are warming at different rates. In particular, the polar regions, especially the Arctic, are warming at rates several times greater than the global average. As a result, as the decades go on, the temperature contrast between the equator and the poles decreases, and thus the jet stream is expected to start to weaken. In addition to this causing it to not move as fast, it may also cause it to move around significantly more, which could increase the severity and frequency of extreme weather events such as the polar vortex in the mid-latitudes. Finally, climate change is causing the jet streams to move closer to the poles at the rate of a couple miles each year. Over long periods of time, this will allow warmer equatorial air to establish itself further north than before, which could have the effect of permanently changing the environment of large swaths of the mid-latitudes. When this is all put together, the result is something that could drastically change the climate over much of the globe, and often for the worse. In addition, the changes in the jet stream could affect the aforementioned dependency on it when it comes to long haul flights. Simply put, a weaker jet stream gives planes less of a push when traveling within it, and if it becomes more wonky, then it'll be harder to take advantage of it for the majority of the flight time. These changes combined could lengthen flight times and increase fuel costs in the decades to come, barring technology that could potentially make the planes themselves fly faster. Overall, climate change is poised to have a significant impact on the jet stream, and this could wind up affecting everything from whether your garden will grow during the summer to how long your flight to Europe is. And that's all I have to say on the jet stream. As always, I'd appreciate you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.